Hello everyone. In this video, I want to look at the idea of heat transfer and essentially looking at the equation of heat equals to the mass of a substance multiplied by its specific heat capacity multiplied by the temperature change it undergoes. So if it absorbs heat, of course, its temperature change should be positive. If it loses heat, its temperature change should be negative. And how can we use that? Well, in this example, it says an architect evaluates different materials to act as heat-absorbing panels for the design of a solar heated home. And to do this, they must evaluate the temperature change of several materials, meaning that if we give three different materials the same amount of heat, which one of them is going to have the smallest change in temperature? That one should have keep the home at the most equilibrated temperature, or at least keep your home at the temperature or around about the same temperature. If the material fluctuates a lot with the same amount of heat, then of course it means that material won't be as insulating, or as good an insulator at least. Right. So in the first one, it says calculate the minimum quantity of thermal energy transfer that is required to increase the temperature of 45 kilogram of granite by 15 degrees Celsius. So this question asks just basically what is the heat that will be absorbed by granite if we have a temperature change of 15 Kelvin or 15 degrees Celsius or whatever. So it gives us the delta T, gives us a specific heat capacity, and it gives us the mass. So you can go ahead and you can calculate the heat using the equation, and you will get a value of 547 kilojoule. The subsequent question then, so that's for granite, right? The subsequent question then says calculate the temperature change of 45 kilogram of iron if it stores the same amount of energy as the granite. So now, in this case, we want to use the equation, but we have the heat, and we want to get the change in the temperature. So we quickly solve for the change in temperature, and you should get that the iron will actually change by 27.4 degrees Celsius. Okay, and then the next question asks exactly the same again, but this time for the water. So let me zoom out a small bit. You can get everything on one page. So calculating the heat, so the heats of each of these are the same, all right? They all absorb the same amount of heat, but we see what differs from them. What differs from them are their specific heat capacity and their temperature changes, because we kept the mass constant and we kept the heat applied or given to them constant. What changed was their specific heat and their change in temperature. And you can see the water by far had the smallest temperature change, and the iron had the largest temperature change. And why is that? It's because the water is able to save, or its capacity to carry heat per gram of substance is nearly 10 times that of iron. I mean, look, if you multiply that by 10, then you get 4.4, and you can see that in the temperature change. It scales linearly. So, and that's why if you stay at the coast, for example, so around about or near a big lake, you have smaller fluctuations in your temperature. Whereas if you stay more inland, where you don't stay near a big body of water, you'll have big fluctuations in temperature. Because water has a nice way of regulating the heat. It takes a long time to release hot water or hot heat during the winter months, and it takes a long time to absorb the heat in the warmer months. And hence, it kind of causes the overall weather to equilibrate in the area. Whereas when there's no water in the area, then it just depends on how much solar energy there is, and then you just burn to death, or don't, or freeze to death. So, I mean, depending on this, probably won't be the best idea to build a house out of water, or very difficult. But in principle, it's not a bad idea. Water will be able to keep the house very constant if you build walls that's able to be insulated with water. The water can actually keep the temperature of the house quite constant. I mean, at least within about 3 Kelvin, given this amount of solar radiation. Because I mean, during the day it will absorb that amount, so your temperature fluctuation is only going to be increased by about 3, and during the evening you should only lose about that amount. So give or take, it should only lose about that amount. Whereas the iron is going to heat your house a lot more and lose a lot more during the evening. So you're going to sleep cold and you're going to live hot in the day. So I mean, that's a it's a very oversimplified example, but it gets the point across. All right, so this basic idea here is actually just how to use MCS delta T, but to also get the point across of how the heat capacity magnitude dictates the capacity to carry heat, as the word says. All right, thank you for watching, and I'll see you in the next video.